So it's easier.
Oh, yeah, right, we can
Second
split, that's
transition.
good, yeah.
Okay.
Thanks, Min, for taking care. Yeah, we move over in the Ask Me Anything session. So it's about ELISA, but also about the use of open source and safety critical system. This is supported by GAP as the governing board chair and the architecture work group lead. So we take this together. The slides are just some high level thoughts from the ELISA perspective. We have this for any kind of open source mentioned there, and it's not limited that Gab and I should give the answer to all the questions. I invite this also to everybody to just share your view on this. If you say, oh, I know something about it, or I have something to express, just bring this up. It's not that it needs to be with me alone or with Gab. So what have I written down? I want to just show like a little bit of bringing up safety integrity standards. This was nicely enhanced by Olivier last year when we gave a presentation, because I made some mistakes in when I just draw things up. So he brought also in the part for space, I guess. He put in a safety certification and also the aeronautics part. You can see that the IEC 61508 and the ISO 26262 are the ones which are highlighted, because a lot of our discussion would circle around this one, these two. Standards should represent industry best practice. I mean, that's a big thing. It starts from experts coming together, writing down. And this may be also a reason why it's so hard currently to map open source against it, because it's called industry best practices and it's not called like community best practices. So that's why we have this on the agenda also. Independent on which standard you have. So I think we took the first half year in ELISA to just fight against each other, which standard is the best one. And well, we learned quite a few things. They all have certain similar demands like traceability, documentation, testing requirements, all these kinds of things. You find this again and again as a repeating pattern, because that's like they represent best practices. You develop similar things, you come to similar conclusions. There might be like variations, but there's a lot of ground to work together. And it just be also the rigor to which things are allowed. So there's something which may be allowed in aerospace, but not in automotive. I think certified compiler is a topic which differs in aerospace. Then mixed criticality is something which is there in automotive mentioned, but I think it's not really there in aerospace. I need a nodding or a shaking hand for you, Olivier, for saying rubbish. Right, but anyway, all system parts need to be known, tested, managed, and that's the thing just on safety standards to get you in. If you're not familiar with safety standards, think about practical way of creating good quality projects, or what the typically people ask you to do. We wonder, why should I do this? Some routes to the safety certification. I heard this also during the intros. So we have cert item here, ISO plus 8926, which is being actively discussed. We should go into the third edition of the ISO 26262. For another argument, it's like the part 8, clause 12 from the ISO 26262, which is there for pre-existing software. I think the most important word is this one, the simple one, which means it's of no complexity. So don't take a Linux system and say, well, it's like pre-existing software component, and I just do a little bit of requirements and testing and I'm done. That's not what it's supposed to be. The simple thing, no, not the simple thing. The way of handling pre-existing software for IEC 658, the Root 3S. This was also where the Silter Linux MP project was looking into, and which is still the path which projects take. And I think the Trustable also goes in the direction of Road 3S, right?
No.
No. That's good. But
We have used it for control OS.
for the control apps.
Not just.
Right. All right. Yeah, that's what I mean. So for the control apps, it's the Root 3S. Yeah, exactly. But there, and yeah, what we know is the challenges increase with increased system complexity. That's an obvious statement, but it's worth to mention because we are now in an environment where so many things getting more complex. So in automotive, you have high performance compute. In aerospace, you see centralization of units because they also want to reduce cabling. They do a lot of measures to just these, and you get more computation performance. You have more demands, requirements, more interactions. And this is a challenge. It's not only a challenge for open source, it's a challenge for any kind of systems. If you use a commercial operating system and you keep the use case of the system, the complexity just get into the commercial part rather than the open source part. The challenge remains the same. And you always need to think about updates, cyber resilience, and so on. There are requirements which come in. You will talk about diagnostics, whatever you have, like any kind of connectivity. So you suddenly are in the radio equipment directive where you say there is connectivity. So you need to find also this complexity from outside in all these kind of systems. And yeah, safety integrity standards somehow need to adapt to the increased complexity of products. And in the morning discussion, which we had upfront, we also just touched on that the ISO 26262 was not made for these kind of systems. In automotive, it was more coming from smaller system size, single control units, and so which just get plugged together. Much better explanation why there is a freedom from interference of different things. And that's like for the standards. You still always need a robust fundament of processes, measures, and statistical analysis. While I feel that's something which is typically taken by almost everybody. So the process part is the most obvious thing. Then when you come into this creating your system, you will end up in the technical measures, and something which may not be really seen so much and not taken too much into account, which come maybe in the next editions of the standards, is like the statistical analysis, because you also need to prove certain things, and it may not be working always anymore to just go from a full deterministic system and everything. So you need to also include statistical analysis as like 3 pillars you're considering. And still, there's really growing interest of open source, because you're all here in this room, right? Which shows that there is an interest of open source and safety critical systems. And yeah, that's basically then also the challenge. How do we get these things in? And I think it's worth to mention, if you look into current existing solutions in China, it's sometimes come as a surprise, but all the things I heard so far, there are actually systems on the field running out there. They are used for ETAS level 2 things. They're purely based on Linux. And even if you speak with the chip supplier, with Chinese SoC vendors, they just provide a Linux BSP. So there is no safety.
It's worth noting that a lot of kind of prototypes of similar systems in Europe and the US as well, they start by prototyping on Linux.
Exactly, and that's there. And then at some point in time, they move over to
the desktop PC in the boot of the car running Ubuntu. It's one example.
Exactly.
And again, a point that we often make is that safety is about systems, not about the individual component. How that component actually impacts safety, what risk it introduces into it, is something we need to consider. But the safety exists and is relevant at the system level. So the fact that you have a component that may not have perfect reliability in some cases, it just means that you need another backup component, a redundant component, to deal with that, because it might do the perfect job most of the time, and for those other times you need something else to deal with it.
Good point. Yeah. Some fundamental challenges, development process, checklists approaches where you simply tick some boxes and someone said, okay, you need to do this in this order, and we need to go through this in this order. You need to show me according to the model, or this is a long list, and then you're done. So this is something which is very hard when you're in a very collaborative, community-based environment. And then it's not that it's not there, but like the formal aspects of traceability, that's something where it's really like there are evidences and the artifacts are there, but it's not fully, it's even manually traceable, but there's no tool support or so in all of open source elements parts. And that's all with also the major things for the open.
Why do we contrast the checklist-based approach to the collaboration of development? You definitely present this as a contrast, that there is a versus.
So I think by checklist-based approach, we mean this idea of you strictly follow a process and tick things off as you do it, which won't necessarily.
It doesn't say that way.
No.
I think.
Yes, so maybe change that to express.
Yeah. Good point.
But that's it, kind of a strictly follow an ordered process versus a collaborative iterative approach is control.
Well, I think there is also another aspect to consider is like traditionally the V model prescribed that you first, define the requirements, then the architecture, and then you write the code, right, to fulfill, these architectural requirements. Whereas in the open source world, really what happens is that the development is code driven. So basically code comes first. And then basically what happens is there is an assessment of that code against, allocated requirements, and also an assessment of the verification methods that, that can be used, in order. How does that contrast exactly, for example, at the end of this process, or whenever you want to release? I don't see this being a contrasting.
So you could have a checklist that you just fill in an arbitrary order for a period of time, exactly. Yeah, maybe we need a
Yeah,
different,
it's
different
I
contrast.
will rephrase.
I think there is greater flexibility, so it's very nice if you would replace it.
I think so. Right, this comes from their like challenges which we see are. We talked about this, like open source is not developed, organized like commercial software. Most of the time, I mean, we have agile development methods and so on, but it's that's what you typically hear if you, so the standard practice which come in is like, oh, it's open source, so it's just chaotic and random. And then you explain the things, and then they said it doesn't fit, means fills also in what we had before. Then like the last influence on maintainers, which is some different. If you are in a company and a person change, you assign a new person, and this person becomes the maintainer. That's not how you can simply do it in open source. If a maintainer stopped working, there's hard times in finding a new maintainer, project could potentially die, or these kinds, so you have a risk.
Or starvation issues, realistically, where basically it's a different management priority for a while, and yes, there's still the maintainer, and then nothing happens for a while. That tends to be a big issue.
But on the other side also, I mean, this is like having no influence on from the supplier management perspective. On the other perspective, we have a strong level of independence because this person will not simply take in your change because you tell them, and there is this risk in a formal development in a company that there's certain pressure or certain things that may come in to force people into a commit or something. Or it's based on price, on deadlines, and so on. And I mean, if you take the Linux release schedule, if a feature is not mature, it will not make it into the next Linux kernel. It will just say it goes into the next version. And I think there's a bunch of people.
Which is why it took 8 years to get preempt RT upstream.
Yeah.
Like, yeah, they just didn't get in until it was mature enough, and then just bit by bit. And it's something which you will see differently in a commercial environment, typically where there's often more pressure. And why you talk about like the safety culture and the standard, why the 2626 where more of this is organized.
There's, I think, more variety, I think, is the point.
Yeah.
And actually, you can't count on a particular set of things applying to every open source. All open source projects are different. There's a lot of variety.
And we have harder times to train our direct developers. So I mean, it's like they're contributors to your project. How do you make sure they bring the competencies? Because that's sometimes what the standard asks for, like, are all these contributions made by experts on the subject matter? And even if we say, okay, I will offer proper training to everybody, it's sometimes even hard to figure out who this person is. You may just have a GitHub handle, right?
So the standards are written with the idea that you have a command and control structure
Which is not.
for your organization, and that
You just pay and you get it.
does
Because
not.
of these challenges, do you find that people then companies within the forking your source code bases more often than not?
I mean, so say again.
So since there's a lack of control over the community.
Yeah.
Companies that are interested in using all this for their projects, like you lack the control that they want from a safety perspective, they end up forking.
I mean, what I experience is that there's a bunch of forks around an open source project, but it's often like you fork them because you want to do a modification and you see it's too much effort to bring the modification back upstream. And it's not going in the speed you like and in the way you like, and then you need to modify certain things, follow coding rules, styles, documentation, and so on. That's at least what I learned. And that's why you say, okay, I better maintain my local fork. It's less effort.
It's not.
It's not, but it feels like being less effort. But it's maybe some later on some for the next day. It's also a good discussion point when it comes to like best practices standard, which we discussed on the third day. What does it actually mean? I was speaking to developers which said, I'm not feeling confident to contribute my software to an open source world because it's not good enough. And these are the people which bring, and it was not safety critical, just to mention this. But they said, or I said, but it's good enough to bring this into products. Right? You release it into a product, but you judge it not good enough for open source. And in the same environment, the people say, if you come with open source is not good enough for our products, but what we deliver in our product is not good enough for open source. So now you have to
In a
check that.
binary, no one can hear you scream.
Yeah. Yeah, liability, I guess I would jump over this. This is not, it's an issue, but it's handleable or not resolvable depending on how you see it. And the last is then the development process around this, because it's not, you have requirements in a way or expectation or whatever you call it, but they may not be structured, written down in a tool as you expected. So it could be an issue system where you collect everything. It could be documented in pull requests. It could be just in the commit patches, mailing lists, and so on. You have these things there, so there are demands for things, but they may not fit into this traditional view. And like, you don't need the traceability because you mainly need the traceability at the time. And then later on, and you have this is just something in there. All right. I jump over this one. Right. For Linux case, Linux differs from a traditional safety critical OS, I would say. What I mean by this is, we have challenges for memory, dynamic memory allocation, caches, real-time, hard real-time capabilities, and so on. This is something which Linux brings. But I mentioned this before with the, like if you are in traditional RTOS and you need to bring this in a complex environment, you have the same challenges, right? You also need to have updates, you need to maintain things, you need to have security respect, and you have this in a complex use case, you need to fulfill this. And it's very hard also in a very closed, small community environment to fulfill all these demands potentially and to create these kind of systems. So you either need to see, how do I make my proprietary things, my safety certified proprietary things ready for the complex use cases, which I will have due to connectivity, due to centralized functionalities, or how do I make the use, like I have my prototyping Ubuntu PC in the back of the trunk of the car. How do I get their safety argumentation? Because here I know how to do all the updates and fulfill all the things, and I have a community guide. And that's basically what's here, but we are a long way step, and depending on wherever you want to go, it's the same for both sides. All right. Let's get into Ask Me Anything. So not spending more time on slides. So you get like the environment in which we are, open source, safety. Just put whatever question you like. Also from the virtual audience, which became 28 in the meantime. Yeah.
So interesting to see that these are the challenges that you have shown on the slide, but how far have you come on the proposals and to overcome these challenges?
Yeah, so
engaging with discussions already.
Yeah.
Philip,
So,
can you repeat the
yeah,
question?
I repeat the question. Yeah, I
Great.
repeat the question. I expected it's not loud enough for the back. Or for the old. The question is basically, there were the list of the challenges and how far are we in the open source environment to address these challenges with ELISA or the wider ecosystem. I can bring up you're basically waiting for this part or in principle? Yeah. Okay. So there are different elements. So one part of addressing is, for example, on the requirements level, are introducing a way how to bring this into the Linux kernel, discussing this with kernel maintainers, is a topic where we progress and where there is a potential solution. The question is it an acceptable solution for kernel maintainers? Because they also need to see the benefit of doing so, but there is a potential solution there. Also, we have another presentation where you have like 6 to 7, 8 different kind of open source requirements tools, so nothing prevents you from using it. First of all, you used doorstop originally to write down expectation with open fast trace in your protocol and in Sen, I guess. Yeah, Sen project also use it. Then we have strict doc and Zephyr, so there it's addressed. Traceability comes by scripting and so on, so this is there. I don't want to say that there's anything on the liability of a community. There's no real intention on this to be liable as a community directly. It's basically handled by licenses and so on to say that you're not liable on things. That's the way how we as community handle liability. And
that's it's important to say that is one of the barriers for open source use.
Yeah.
Is that if you've got nobody who is liable for it,
But if you-
that is a real problem.
but if you take, for example, from the Eclipse Ascor side, where they explicitly have an integrator, distributor
Yep.
role, this integrated distributor will take certain liability, I expect, and will be liable for things which are delivered in there. They will take liability on this and taking the risk, but getting paid for the risk.
Ability is a business model.
Yeah, liability is a business,
That's-
definitely, yeah.
That's the business plan.
So you're insurance company in the world.
For training this for the training and developers, this happened actually. So there has been in Zephyr there have been trainings, and then have been trainings for contributors. There's been Mistral trainings, for example, also, and
We had
I
some
see
training
things-
in ELISA of how to submit a patch to the Linux kernel.
yeah, this was the other way around to train the safety committee, also how to do the training like this. It's not directly for the open source developer as such, but it's more like the general training.
We are an open source project.
Yeah. And I think that's, so the maintainer part, it's mainly about an argumentation, and you can do a good argumentation. And you can also somewhat prove that there's an expert. It's just very hard to say like, well, I sign with blood or whatever that this is the person, but you can show that there is evidence on the technical capabilities of maintainers for, let's say, for professional open source project, because it doesn't fit to all kind of hobbyist open source project, right? And this is often how you compare things with, right? But taking an analogy, if you cannot compare it like this, because if you would say, well, there's this guy building a go-kart in his garage and goes on the street, you would say this is not professional way of creating a car, right? But if you come to the open source part, you sometimes argue like this and say you cannot use open source in a project because it's done by hobbyists, and that's not the case. We're talking about professionals here,
Right.
which are doing a part of the work.
The other side, on the hobbyist side, is I'm thinking of the APS, open APS system, which
Yeah.
started out as a hobbyist. And then later the FDA actually said it was good enough. Because it didn't, and because it was a hobbyist, it didn't have the liability issues. So there's some interesting models out there we can experiment with.
Exactly.
Linux somehow started as a hobby.
Which one?
Linux.
Linux stuff is hobby, yeah,
But it's, yeah,
but
but
we're still.
that's a while ago.
And
It is.
I mean, and what you really need to see, like for these challenges, it's not always that, it depends on how you do the argumentation, but we have, like in this room, we have, and I will miss definitely some, but we have Electrobit, which provides a solution where you can have safety critical workloads running on a Linux system. I'm not saying it's a safe Linux, because it's not. And we have CodeThing, which just had the press release out there for the control part, which is a Linux-based system which can be used for safety critical workloads. We have Wind River. They are not making so much noise and public marketing, but I mean, if you check for ask ChatGPT or whatever is a preferred large language model and just ask like who is a safety Linux provider, then they would typically tell us Wind River. But if you ask more in detail, you figure out that the large language doesn't know details and it's basically mix up safety and security. Anyway, there are solutions out there. Bots provide them. Red Hat is the most prominent one, going really on a safety Linux and making big progress in there. So SUSE is having this in the past. They had also the ASPICE compliant words going for it on it. Exploring it a little bit. Canonical having a long way to go. That's what they say on their own. They don't provide a solution. They also partner with Electrobit on this, but you see there are, and then other things where this has just been solved, where you start with safety in mind. With Zephyr started with safety in mind in the beginning, right? Then started with security in mind, adding safety parts on it. But you also have the L4A part as the CAN concept hypervisor, which is also in the Electrobit solution. And then there is ThreadX from Eclipse side, which is safety certified, but this is like cheating because they have been safety certification and just open source it afterwards. And now
We're recertifying it as well.
you're currently recertifying, and it takes certain time because now suddenly you need to are confronted with these two parts, for example,
And
less
cost.
influence on maintainers.
And cost.
Cost as well, yeah. But that's really where you can see there's progress on it. And another progress which has happened, which is just in the page step size, is what we do with the best practices standard, because this is not about safety, but it's to show like what are practices established in open source, which can be used to create higher quality commercial software and to judge KPIs for open source, which falls in the trustable side. Trustable also brings in this intentional, we have this there, and there's good steps forward, I guess. And it could go much faster for some parts. It always depends on how serious you take it, how much capacity you have from the people for all these initiatives. But the challenges are progressing to be solved in many areas.
The challenges are progressing.
The challenges are progressing.
The challenges don't go away.
No, they don't go away.
We can't solve the problems for you, but we can help you to solve the problem.
Go ahead, Jesus.
I have a bit, maybe a more general question. The approach is more like rethinking the standards so that you can evaluate open source software in a new way, let's say, because open source software is different from the research in the 90s that led to those standards, or the other way around. In fact, to try to find a way of certifying open source software with the current standards.
Both.
Those are.
You are repeat for the mic, because I don't know if you pick up places.
The question is like in which direction we treat the topic, if we apply open source to the safety standards or influence the safety standards to include open source, right? This is this fundament of the question. And both directions actually, I mean, you have use of systems which include open source software and which have been certified according to an ISO 26262 or IEC 61508 or medical standards. So you have this part, and you also have like the additions with the ISO pass 8926, where you bring in complex pre-existing software into the ISO standard. For both directions, you can find arguments if it's good or bad, right? It's not like the ISO 26262 was not made for this kind of huge consumption of open source software, and it's like a big challenge to bring in open source software into this framework of the standard. So it's also not an easy choice to say.
So basically, there cannot be an official collaboration between ELISA and safety standards as entities, right? Because of violation of licenses and stuff. However, people that are part of ELISA, some of them also participate into the safety standards, right? For example, I took part in the draft of ISO pass 8926. Now participating in the third edition of ISO 26262 activities. So on one side, we are trying to evaluate the standard and adapt them to also consider complex pre-existing software. On the other side, in ELISA, we have our set of activities to build ingredients that can be used to support, a safety claim. Not with that, not following
to the left, close by close, the safety standard, because, it's a complex software that is not written for functional safety, you cannot like change, you cannot make a revolution inside Linux, to follow part 6 of ISO 26262. However, what we can do, we can start, to identify, the high priority components, and start to define requirements, trace requirements to test. We'll see, later in the workshop session about Basil, how we link to kernel CI, requirements, and so on and so forth. So this is,
I'm
this
asking
extent.
it because of that, because it seems that most of the standards were designed when software were thousands of lines of code.
Yeah.
Right now, we're talking about millions of lines of code.
Yes,
And that means that from some points of view, standards are not valid. In the case that if you want that quantity of software, it doesn't matter if it is software or not. It matters that it's a lot of software, and the standard is not designed for that. So
Yes.
maybe what we need to change is the standard,
Well,
not the code. But
there are some members in this room that are working in the standards committee from that perspective. And then on our side, we're trying to work with the open source communities for the underlying pieces that need to be put in place, like that everyone's gonna need like requirement traceability. And figuring out how we can get that level of language introduced into the community. So there's work going on in Linux on that front, there's work going on in Zephyr and Zen on that front. Obviously Rust as well. So like I say, we're tackling it from both sides. But it's not a simple solution because there was a gap.
Yeah, we can't simply, we haven't got a checklist of problems we can go through and solve, and then it'll all be done. It is more about enabling people to grapple with these problems. And I think a really important part of what ELISA's achieved over the years is bringing the two communities together so that they can actually learn from each other. So that the open source community can say, actually, no, I haven't really thought about it from that angle, or maybe that is useful. But also the safety community saying, yeah, you're right, this really isn't what we thought software was. And yeah, the whole idea that software in some of the standards, it either works or it doesn't. It's
Deterministic.
it's deterministic. It doesn't have like a failure rate. It just works or it doesn't. That's it.
Igor, you were looking like you want to say something.
Feel free to
If
go.
you don't want, I don't want to rush into something, but you were looking like you want to say something.
Well, the thing is, there's a strong risk of trying to bend the standard to the point that I can get my wish granted while forgetting the reason why the standard was written. And that's something that I kind of felt like when there. That's not good in my opinion, because in the end, you're still, the first goal is safety.
Yes.
So if I cannot use Linux the way I would like because of safety, well, that's a valid outcome. I'm not here to say that Linux cannot be used, quite the opposite, but
I have a question, yeah, so a nice overview of all the companies that are investing a lot to make Linux usable in a safety environment. But yet, if I want to get like a middleware from a company like ETAS, then I'm probably gonna have to take some proprietary thing, right? A German OEM this morning told us the problem is that we need to write down our assumptions of use. Is that the blocker? Or if not, why if I go to ETAS, why can't I get your middleware with Linux? Like, what is the block?
So before we go into what asking me is ETAS, I say you can answer most likely the question on your own because it's electropaper, which works in a similar domain. Maybe it's a fundamental automotive issue first of all, which we have been in like the hierarchies, liability things and so in the past. Of course, this is getting addressed now in the Eclipse world with the ASCOR project. That's maybe also the direction where you want to push me into mention this, because I know you know about this, but also there, if you see the ASCOR project, which tries to get an open source middleware stack, although they struggling to a certain extent how to make use of pre-existing open sourceware to make it compatible and give the argument for the safety integrity standards. But what they do is, I say, they take the best practice and say, okay, we want to have traceability. We write down our requirements and so on. So we fill the gap in what is needed, and we do this in the open. And this is basically what you would do also in your closed environment. I mean, how do you get the things? And it's like you fill the gap, you give an argument, and even if you take it just for QM software, if you're in the ASPICE automotive environment, you will ask your supplier to comply to an ASPICE process. So they will have an ASPICE process, how they consume software and how they handle it. And you can have a supplier for a Linux system, which is ASPICE, delivers ASPICE compatible project execution and work with the base of open source software in there. Basically, Susan was giving a presentation on this 2 years back or so in the.
Yeah. The challenge is that the system is what it needs to be made safe. The open source components, be they the Linux kernel or be they a set of middleware, have not learned to speak the requirements language such that you can have the traceability down to the system level. So by finding the projects that are most important and working with them, we're hopefully setting a pattern for the rest of the open source projects to work from. Like I say, there's no magic solution. We've got to do the hard work and build it up over time.
But just one comment to tie your two comments together. While not necessarily, you know, done deal, everything is consumable directly, etc. You will have to put in some work. You always have to put in some work as the system builder.
Yeah.
But we have, other than SCORE, we have multiple open source projects that are being built by people with this kind of goal in mind. Like ISORix 2 comes to mind, the Raspberry Pi, there's a company behind that, small company, but still these guys are building that code base to be used in such systems. We have our U protocol project. We have, I believe, a lot of the meta, you know, the requirements of the traceability and all that jazz, we have that. Now, the problem is not some supplier not, you know, willing to sell you something. That's one part of the problem, but, you know, there's only a seller, there's a requester. If nobody wants to integrate this stuff, well, you know, and right now, people don't want to integrate the stuff because they've never done it that way, right?
Mhm.
And that is, I believe, like the chicken and egg thing that we really haven't gotten over for 10 years now.
I get the same feeling you have, that said it's more about inertia than
Correct.
anything else.
On the technology level, I'm pretty certain, and also on the quality level, everything that we could possibly need exists. Are we willing to use it? Well, not really. So
I would go into a last question. If someone still has, yes.
I'm sorry, maybe it's a very beginning question, but that question brings me here. So I would really like to ask the expert here. And my Philipp. Yeah. So I'm a DevOps engineer student here, and there's a question that bothered me on the first day when I studied Linux, which is after you installing a system, the first command you use is always like the sudo apt yum install or update. And when you use that command and boom, the thing's there. It's run automatically. It's like the black box, and I don't know what's inside. And how do I actually know like what I'm installing and updating is secure and trustworthy? And this bothered me super a lot. And everyone just tell me like you run this command, then the thing's there. So
That's commanding. Everything comes from the
Yeah,
internet.
no, so I think it
Everything
depends on where you're getting your distribution from. And then what processes the people who put the distribution out do. Usually they will basically make it visible what is in an update and a commit. And so you have to go to their site and understand what's there. And it becomes an element of trust as to, do you believe that they know what they're doing and have done the right job to a certain extent. But that would be how you do it. You should be able to go and query the images and actually find out all the commit logs on those images, what's there in certain cases. Specifically for some of the open source components, you should be able to do that. But one of the big challenges in safety is going to be, as you're getting all these fixes in, and from the Linux kernel perspective, Reg is treating everything, any bug fix as a potential CVE. Being able to track that and figuring out when you need to update is going to become a challenge. And so security and safety are going to need to work with the automation together over time to make these things more visible as to how we approach this. But to a large extent, it depends as I say, from the security's perspective, what's there? You need to be able to go to your supplier, query it, or, you know, and they're potentially even track it back to upstream. And understand what's there.
And what you also see is when you install, you download a image, you install it, and then you do the update part, and you see all this. This is because it's like fitting most of the use cases, so it's full of packages. And just saying, like, if there's like 25,000 packages around, I think the Red Hat Enterprise Linux roughly is about 5,000 packages, which are roughly, and the Red Hat in-vehicle OS already goes down, or the CentOS goes down to
An order of magnitude less, something like that.
500, something like this, right? Like in the range. So you see it, and if you see the things which we created, so we start building Linux systems at Bosch Spike 2011, 12, something like this. And the first thing when we had the Linux, like what we stripped down was like, oh, we don't need the CUPS printing system in our machine. Oh no, we don't need the USB keyboard support in our infotainment device. And by stripping down, we came to a limited set of 100 plus packages. And if you see like this, there's a civil infrastructure platform project, which was mentioned here. They use a Debian system and they say, we have a core, which is the fundament where we rely on beside the kernel, which is a set of 10 packages where they put in the highest level of trust or responsibility, not trust, but they say that's our area of core interest. And we extend this to 100 packages, which are extension sets. And if you imagine now you have a Linux system optimized for use case, and it's somewhere between 10 and 100 packages. If you do an update, you're well aware of what you're doing there. And if you bring this into a device, not so if you don't bring this directly into a car, what you did all in this image, you will actually switch this kind of update mechanisms off normally. So at least you will have a shell where you connect to the internet and just download packages. That's typically what we would switch off in production, would control the release of things. And this control of releases and this shortening of packages, that's also what happened at Canonical, SUSE, and so on. They also select which they take in, and still, last part, issues can come up because there was like the 2504 release from Ubuntu recently. I don't know who read about it, but Ubuntu, like the KDE version of it, failed after installation. So you had a black screen. And this was quite shocking for me at this moment. I thought, okay, because I was running it on an old PC, and I was like, I haven't installed it, was not offered the update. I was just surprised that it's like, okay, that's the Ubuntu one, that's the original one, and it just fails to update. It means like, what in the testing procedure has gone wrong? It can still happen on this, but they take rigor and limiting down the packages, control them, and then you need to say, okay, I download from Canonical, and I don't download from Philips image, which I have.
It's very valid point. Unless you.
Ubuntu is the official.
Kubuntu, it's called Kubuntu, but yeah.
Yeah, but it used to be, but lately they switched to support officially only GNOME.
Oh, really?
Yeah.
Yeah, so it's
Oh,
a
then
sort of
it's-
community thing.
Okay, then it's not a.
Unless you change the mirror, that's all. But the
But
point is
yeah,
still
we
valid.
have
The point
so-
that our fellow student is raising is still valid. Dev RPMs are not really reproducible packages. There are reproducible package managers and Linux distributions, MixOS. I hope I won't them. These distributions guarantee that what you build is what you expect to be. You can cross-build it yourself, and you can confirm what you're receiving from the internet is correct and accurate, always. I mean, there was a blog post recently that says that there is a 3% deviation in very specific packages, but that's something that they can guarantee. As they the colleagues correctly say, is that updates are normally disabled on a live system, which could cause harm to people and they're very controlled. But still, that doesn't prohibit from a supply chain attack, for example. So, and the system needs to be, again, we go into system protections, domain protections, specific computer protections, many. So you have a layered security, perhaps a zero trust security, try to protect your system from upgrading. It's a valid point though. If you see any Docker Linux getting built, the first step they do is update, update, you know? And then, you never know what the Docker contains. It depends when it was built.
Right, paranoia is good.
Yeah,
You're thinking about exactly the right problems here, and it's often something people miss. Because they experience it through a desktop environment, they think, oh, well, that must be how I do it, and then you look at how an embedded Linux distribution or embedded Linux system is
So-
built, and it's very different.
It's a very large market right now on the embedded side in terms of for the embedded IoT devices, which also potentially is aligned to cars and so forth. So where basically there are people making businesses on managing all the distributions and all the updates for a set of embedded devices. One example, just to give you the scale of it that's happening, is Tesla actually maintains a digital twin, not just of the line of car, but of every car they sell. Okay, so the stat I found was there was 1.8 million in 2023 digital twins created, which is effectively the transparency of exactly which version of software is working on which subcomponent within that system. And that's the level we're gonna need to get to in order to do a sense of safety. Now, I've got other issues with the Tesla stuff, as do some of others in the room, but the fact that they are keeping this type of digital twin, this metadata about each system, I think is showing you sort of the level of component. And then when you start looking at the level of all the supply chains and all the OEMs and everything else, there's a lot of things that are going in and updating things that, as you interact as a system, may cause issues.
That's it, if you don't have good, very, very minute control over how you're building a system, that is the kind of thing you need to resort to. It's okay, I accept it, I can't perfectly reduce it, so I'm just gonna track it for every single thing I'm doing.
I think you sometimes just have to, even if you have a decision, because
And this is a really important thing, because a lot of sort of traditional safety approaches, the idea you make a piece of software, you make it as small as possible, it lives for 15 years and don't touch it. That's very different to the kind of software we're talking about. We're talking about software that is going to change, it's going to be updated, but we're expecting it to change to grow.
and as we here in Europe, as we're going towards CRA, there's expectation of the longer life cycles that are going to be playing a large role, especially with the updating up to like, depending where it is in the ecosystem, up to like 30 years type of deal. And to keep software going for that period is something that the industry is going to find a challenge. And quite frankly, a lot of the stuff we're going after with safety is pieces it's going to need. Yeah, go for it.
I have a question. Certification for me is like a snapshot. You comply at this specific moment that you just addressed with the digital twin. Then you can have compliance related to the digital twin continuously.
And
Is that something?
Yeah.
the way where things need to go.
Yeah, like I say, the whole notion of coming up with metadata to describe the systems and so forth. And being able to reason about it, be able to know exactly what you need to regress test, what you need to basically do, that is the direction we're trying to take some of this stuff in. So that we have continuous, if you hear the phrase continuous compliance, that's shorthand for what we're trying for.
Yeah, so that's basically the trend is basically to be about moving from a static process safety audit that supports a certificate toward the a certificate framework where you have like some KPIs that you use to evaluate continuously if the certificate is still valid along with the evolution of the code. So it's like having a dynamic PSA supported by a certification framework. So that's the deal.
Which usually you already have in place, that's usually what is called minor update and major update. Usually when you call a certificate, so for example, aircraft are usually updated twice a year with the same certificate. Because it's considered to be a minor update that doesn't need to require to redo the safety analysis. So you stay within the scope. So you start to build integration rules. And as soon as you stay within the integration rules, you're in a minor update and you can do an update. But as soon as you start to break the rules that were presented to do the certificate, then you need to bring an auditor to review that your change is safe again. So that's in this area, as Gab was saying, that we can extend that definition of minor and major update and how we define integration rules. That would be a way to keep the way safety is done today without breaking everything, because that may take years. So changing this kind of definition could be a way to be able to do more update and see that it's a reasonable one.
And maybe to add to that, I believe the challenge in all looking especially at the back row, is that you have to do a huge amount of validation. If you do a major update, and the question is always how can you write it, because it simply costs money.
Right. So I don't know if it was audible for the virtual ones, but it says like we need to do a lot of validation, and the efforts it costs a lot of money to do. If you do a major update, you have major validation efforts, and these huge efforts cost money, and that makes it very expensive. So you try to get also more to handle things in minor thing. Well, where you can. Good. We're having the very last question.
Yeah, last question.
Yeah.
Everything that you said about the word certification. Actually, I just want to clarify again. So certification in the context of it is a certification done by a certification body. So the paper with a stamp saying that you did everything that you needed to do based on a certain safety standard. Is that right? Because why I say this, it's because certification is not required by those standards. What is required is a classification, an evaluation, or a qualification, but certification is not required by ISO 262, IFC 61, etc. So I just want to clarify again the definition of this word in ELISA.
So the ELISA also has no plan in doing certification. There's nothing, and the certification is something for the later per company which create the commercial product, and if they consider that they need a certification. And I mean, the main thing for a certification is that they say, okay, I have an external authority which also confirmed that the things I have done are the things which are expected to be done.
And I think that's a really important point. We often focus on getting a certificate as the goal, as the end goal, because that is actually how it is usually presented when somebody says, I want to use open source, but can you give me a certificate to say that it's good? But only for commercial. Exactly. And this is so as
From the standards,
yes.
we would need safety case.
Yes, exactly.
That is important, that
That's
for
right.
each major update or minor update, depending upon the case.
And I was
The safety case, a valid safety case is needed.
I was speaking to someone from a certification authority recently. I don't know if you want to be quoted or also the company name should be mentioned, but just saying this like it. What he said was, often you get the certificate and the things because you developed in a proprietary environment and you don't have a chance to see what all has happened. So you order an external certification authority, which gets certain insights into what we have done that you don't have to show the others what you have done. And by this, if you bring this fully in the open and having it open source, there is less need or no need in extreme case for having a certification on this, because you have the chance on your own as a user to see all these kind of things. You have the transparency, and the certification is there because you don't have transparency. And I found this also, we had a longer discussion on safety manuals, for example. And the safety manual is there that you get a manual on this proprietary thing that you know what you should do and what you not should do. But if you are in the fully in the open source world, you could also argue that you don't need a safety manual, because everything which is in safety manual you can put anyway in your normal documentation, and you don't have anything which is hidden behind. So you don't need any kind of safety manual anymore, because it should be a help for the user, and you can bring this anyway directly in the open system. This is the way of things progress.
So I've heard certification characterized as marketing material.
Yeah,
It is.
Another way to look at it, in the same way that the safety manual is that it's the commercial contract. It's saying, I am saying this. I have this body backing it up. Yeah. Exactly. So perhaps this is an important thing for us to consider is rather than thinking about certification as the end goal, we should be thinking about a safety assessment of our safety case that is actually confirming that it flows. Yeah.
Criticism
Yeah.
is useful as the water application because that is paying company to say that this is.
Yeah, exactly, yeah.
Go ahead.
I think you raise a good point because there are different kinds of certificates. If you talk about the automotive market and the fact that you got exactly as Philipp described, someone that look into your environment, what you did, you get also an agreement from the automotive community, for example, that it's okay. But if you look at the aerospace market, if you go to the industry, it's different because you have a regulator. Exactly. Which comes back. And they give a different certificate that usually is based on the one we were talking about, which is an authorization to sell, fly, and install, which is different. Which comes back to the question before is, do we try to follow the standard as they exist, or do we try to find another approach? And right now we need to do both, because for the market where you need to have the people of the regulator, you need to change the mind of the regulator to do something else, and it takes time. So trying to follow the standard as they exist, that's the fastest path to get it approved by the regulator. For the market where you don't have the regulation, it is where you can try the other path. So you can build the trust because safety is about confidence. So you need to build that trust. And for the regulator, you need to transmit that trust to the regulator and that gets you there. That's a good question.
And by this, you can talk as much as you like and continue in the break. And I really like that you favor discussion over having a coffee. We have the idea of the workshop, but I want to keep you away from it. So we take then not the half an hour as planned. We take 15 minutes break. I call you in 3:05 again. We'll stop the recording here, I guess.
Yeah.
And I would like to take a group picture when we return, so like getting once to the front. Then we sum this one, have a checkbox on our checklist from things to do during the workshop.